Hello, welcome back to Algebra 1 with Mr. Farina. Today we will be discussing 9.2, which is multiplying polynomials. The other day our main focus was on adding and subtracting polynomials, so today we will head to multiplying polynomials. With multiplying polynomials, our main focus would be multiplying monomials times binomials, multiplying binomials times binomials, and then trinomials times binomials. Now, to take a look at reasons why we do some of the things we do, we're going to use expressions without variables at first, starting with a monomial times a binomial. If you remember order of operations, if I give you the problem 3 times 2 plus 1, basically our common math tells us to do what's in the parentheses first. So we would do 3 times 3, which would give us 9. Okay, but what happens if we cannot combine like terms? Okay, inside the parentheses. If I go ahead and distribute to 3 times 2 would be 6, plus 3 times 1 would be 3, and if I add these together, that would give me 9. Basically, a monomial times a binomial, or a monomial times a trinomial, or any monomial times a polynomial will always be just you using the distributive property. Now, where it gets a little complicated is once we bump up to the binomials times a binomial or trinomials times a binomial. When we look at this, if I gave you the expression 4 plus 1 times 3, say 2 plus 3. From the beginning of algebra, using order of operations, initially we would do what's in the parentheses first to get 5 times 5, which would be 25. Okay, but again, going back to what we discussed in the monomial times a binomial, what happens if we cannot combine like terms inside? Well, how could I get that same answer 25? Well, first, if we go ahead and take each term from this first set of parentheses and distribute it to that second binomial, that would get 4 times 2 and 4 times 3. Then I pull out that second term, which happens to be the 1, and I distribute it to the 2 plus 3. Once I go ahead and distribute, I would get 8 plus 12 plus 2 plus 3. And now if I add these together, 8 plus 12 is 20, plus 2 is 22, plus 3 would be 25. So notice, if I distribute each term in the first quantity to each term in the second quantity, and then combine like terms at the end, I would get the same answer as if I was to combine like terms and then multiply the products out. Now, same with the trinomial. If I look at a trinomial, that's a polynomial with 3 terms, such as, actually, let's get rid of that. Let's do 2 plus 1 plus 4 times 5 plus 3. Okay. Normally, again, we would do 2 plus 1 is 3 plus 4 is 7. And 7 times 8 would give you 56. Well, now if we take each term in that first polynomial, which is 3 terms, and we distribute it to all the terms in the second set of our second quantity, we would have 2 times 5 plus 3. Pull out the 1, distribute it to the 5 plus 3, and then pull out that 4 and distribute it to the 5 plus 3. Well, when I do all my distributing, 2 times 5, 10, plus 6, plus 5, plus 3, plus 20, and plus 12, you notice when I add these all up, I would get the same answer, 56. These kind of math principles are basically what we're going to use to help us multiply polynomials with variables. So starting off with a monomial times a binomial. Again, this is just our basic distributive property. We're just going to distribute this outside a to every term on the inside to get a, b plus ac. Now the one thing you have to keep in mind with this is when you distribute, you multiply the coefficients, and when you multiply the variable expressions, you add the exponents. So here, I would have 2x to the third times x to the third would give me 2 times 1 is 2. X to the third times x to the third is x to the sixth. Next one, 2 times 3 is 6. Since it's positive, we add it. X to the third times x to the second, x to the fifth. Next, 2 times negative 2 is negative 4, so we would subtract it. X to the third times x would be x to the 3 plus 1, which would be x to the fourth. And then we have 2 times 5 is positive 10, x to the third. Now, once we distribute, then we look, are there any like terms we can combine? Nope. So that's our final answer, written in standard form, in descending order by degree. Now, moving to the binomial times a binomial. Okay, when we do this, we set up above that it's very important to pull each term out in the first quantity. Alright, so each term of the first binomial has to get distributed to the each term of the second binomial. So when I look at this binomial, then I look at the other binomial. I'm going to pull this first term x out, and I'm going to distribute it to each term in that second binomial. I'm then going to pull out that negative 4. Okay, and since it's negative, sorry about that screen, since it's negative, I am going to pull it out as negative 4 times 3x plus 2. Now, I do my distributing, 3x squared plus 2x. Then, negative 4 times 3x is negative 12x. Negative 4 times 2 is negative 8. And once we're done with all that, we look for any like terms we can combine. If I look at these two middle terms, I can combine those. So, 3x squared minus 10x minus 8. And that is our final answer. Okay, if you'd like, you're more than welcome to pause and try the next example on your own. So let's look at this. My goal in this problem is to pull each term in this first quantity and distribute it to everything in the second quantity. So what's the first term here I'm going to pull out? I'm going to pull out that a, and I am going to distribute it to the 2a plus 1. Then I'm going to pull out the positive 3a and distribute it to the 2a plus 1. Now, once I distribute, remember a times 2a is going to give me 2a squared. A times 1 is a. 3a times 2a is 6a squared. And 3a times 1 is 3a. Now, looking at this, I would go ahead and combine like terms here. And 8a squared, combine like terms here, plus 4a. Generally, we would not have this a here. Okay, but before I started the example, I didn't see it there, so it just followed it through anyways. So, keep in mind that each term in the first binomial has to get distributed to each term of the second polynomial. And once we distribute, all we do is look to combine like terms. Now, what happens if we have a trinomial? times binomials, or even trinomials times trinomials. Well, the only thing that really changes is the number of distributions you have. Okay, one thing you need to know is the number of distributions you will have will always be equivalent to the number of terms in your first polynomial. Okay, so remember, when we have a trinomial, 3 terms, times, say, a binomial, which has 2 terms, my goal is to multiply everything in one polynomial by everything in the other polynomial. Okay, so let's look at this first example. Now, my first term here is b squared. I am going to pull out the b squared, and I'm going to go ahead and distribute it to that second polynomial, which happens to be a binomial. I'm going to pull out that 6b. Okay, that's my second term right here, and distribute it to the 3b minus 4. And then finally, I'm going to pull out that minus 7 and distribute it to the 3b minus 4. Once I have all of this written out, I basically go ahead and distribute. So b squared times 3b, 3b to the third. Remember, we add the exponents. b to the second times negative 4 is minus 4b squared. 6b times 3b is going to be 18b squared. 6b times negative 4, negative 24b. Negative 7 times 3b is negative 21b. And negative 7 times negative 4 is positive 28. You'll notice we do end up with a lot more like terms that we have to combine. So starting with the 3b to the third, are there any other 3b's to the third we can combine? Nope, so bring it down. If I look at the negative 4b squared, okay, I can combine that with the 18b squared. Now, negative 4 plus 18 is positive 14, so we would add this term. Negative 24b minus 21b is going to give you negative 45b. And there's nothing to combine the 28 with, so we just write it down. Notice, we have no more like terms to combine. Our polynomial is written in standard form, and we have just multiplied a trinomial times a binomial. So, as soon as we start getting better with these, you don't have to write out and show. It's not extremely important to show this step. But when you're first starting out, it's not a bad idea to do. Generally, what I like to do is just hold my finger on each term in the first polynomial and know that I got to distribute it to every term here. So 2y times 3y squared, right away I would just write 6y to the third. 2y times negative y is going to be minus 2y squared. 2y times 5 would give me positive 10y. Now if you notice here, we're multiplying a binomial times a trinomial. So if I look at that first polynomial, I'm going to have 2 distributions. The next one would be the negative 3. Negative 3 times 3y squared, negative 9y squared. Negative 3 times negative y, positive 3y. Negative 3 times 15 or 5 is negative 15. Now we are ready to combine like terms. 6y to the third, nothing can be combined with it. Negative 2y squared minus 9y squared will give me minus 11y squared. Negative 10y, or sorry, positive 10y plus 3y will give you plus 13y. And then you got minus 15 left. And we're written in standard form, and we have just multiplied the binomial times the trinomial. It is very important to know the number of distributions you would have, and don't forget to keep an eye on your signs. Alright, say the signs in your head, negative times a positive, negative, use a minus, and just be very careful and organized. Have a good night.